Good morning to all. Myself Shreya and today we are going to start a new topic of math which is elementary shapes. So let's start. Now this elementary shapes is just the part of the geometry. The geometry which was our previous topic of the math. It was just the basic idea of the geometry and we are going to learn deep in that topic. So let's start with the elementary shapes. Now before starting, as we had learned that this is just the part of the geometry, we are going to start with a little fun and tricky image. So let's see that image over here. Let me bring that. So I have my tablet like this over here and I have that image. Now the question is that how many legs does this elephant have? A little tricky image, right? So many people will say that there are more than 4 legs, right? This seems as a leg. This seems as a leg, this and this and this. So there are just more than 4 legs. It seems like that. But is it the real thing? Is it the real thing? No, not. As we already know that the elephant is a mammal and that has the 4 legs. So how can it be possible that it has more than 4 legs? Now, this image is just the example of the optical illusion. Let me highlight that. Optical illusions. Now, what are these optical illusions? So, the optical illusion is the image or the illusions which trick your mind. What does it mean and how does it tricks your mind? Let's see. So, the optical illusions uses the colors, the diagrams, the shapes and then create a little tricky images which trick your mind. How does it happen? Okay, so what is the name of that illusion? Optical illusion. Let me write down. Optical illusion. Now, as we already know that the optical nerve. Do you remember that optical nerve? What is that? That is a nerve which connects our retina or our eye to the brain. So that is known as the optical nerve. I think you guessed. Yes. Optical illusion tricks your mind with the help of your eyes. What does it do? So firstly our eyes take the information, take the things which it sees and then that information is processed by our mind. But what does our mind do? It start relating that image to the real world and it also interrupt that, and because of this our mind forms an image that something else than what is this. Like that elephant. We already know that elephant only has the 4 legs. But it seems like it has more than 4 legs. And that is the little trick from the optical illusion to our mind. So now that was a very interesting thing. And do you know that the optical illusion, as I had told you, it is formed by the shapes and also by geometry. Now let's move on. Let's talk about how to measure lines. Let's see that. So over here, let me rough this out. Now, if I want to measure line, let's say this one, if I want to measure this line, what I can do? So I can measure this line, or let's say two lines are there. Now, which line is bigger? So we can tell that who is bigger by the three mediums. What are they? First is the observation. We can just see and tell that this one is a bigger or this one is a bigger. Then we can use the ruler. What is a ruler? The scale which we use daily. Just measure this length and then this length and then compare that. Very simple. What is the third one? What we can use next other than the observation and the ruler? Right. Divider and ruler. Now, what is a divider and how does it looks like? How can it help in the length, in measuring the length? So let's see. So our divider looks like the compass, something like the compass. And as we already know that a compass like this, now it is something like this, and the pencil is fitted. I've drawn just this roughly. So our pencil is just fitted in this hole, and at this tip there is a point. So our compass looks something like this. What happens with the divider? It looks like this. Now we know that the compass has a compass tip and a pencil tip. Because it is a pencil, so obviously it was a pencil tip. The pencil is fitted at this side, so it is a pencil tip. Now, what happens in the divider, that it has its own two tips. Right over here and right over here. So how can it be useful for measuring the length? Very simple. What you have to take that divider, stretch it and take the length. What does I mean? Let's say if I want to measure this length, so I will take my divider and place it like this. I will take this length and I will take this length. And then just take this, just hold over here and take this divider and measure it on the scale. This point will be at the 0 centimeter and this will go the centimeter, the length of the line. So that's how we can measure using the divider and the scale. So what will be the accurate measure? So basically, let me tell you that the accurate measure, the most accurate measure from the three mediums, three ways. We have learned 3 ways to measure the length or to compare the length. So out of these 3 ways, who is the very accurate way for comparing length? So the accurate way, let me tell you, is using the divider and the ruler. Why is that? It could happen that our scale is not perfectly aligned and it can be a little wrong. 1 millimeter wrong, 2 millimeter and so on. So it could be a little wrong. But using a divider, it is most accurate from the three of the ways which we have learned. So, what is the accurate way? What is the most accurate way for measuring the length or for comparing the length? Divider and scale or a ruler. And let's see one more thing over here. Let me draw a figure again. So, now I have two lines. Now tell me who is the bigger, this one or this one? Basically, AB line or CD line, who is the bigger one? Now most of the people will say that this line CD is the bigger. But in the real, basically these both lines has the same length. Right? Let's see. So if you don't believe me, let me draw this again. So if I'm going to draw this again, firstly I will take the two lines of same length, and then I will draw like this, the arrows and like this. That was the same image, right? So these arrows, this image is also a famous illusion. It is known as Muller-lyer illusion. Okay, let me write down that. Muller-lyer illusion. Yes, Muller-lyer illusion. And this illusion make you believe that this line with the arrows outward is bigger. It looks like that this line is squeezing and this line is stretching. So this is again a famous illusion. We have learned two illusions, optical illusion and Muller-lyer illusion. Let me draw one more example of the Muller-lyer illusion. Let's see that. So let me have another image. Let me draw this. Now, who is bigger? Basically, whose area is? These are the two rectangles. Whose area is larger? Now, it seems like that this rectangle has the larger area. But, as we had already learned, that this is nothing with the Muller-lyer illusion, and these both rectangles has the same area. Just because of these arrows, what happened that it looks like it is stretching and it looks like that it is squeezing. So very simple trick. Let's move on to the angles. We have learned in the geometry first the point, then the line segments, And now let's see the angles. So let me rub this out. Now let's see. So we had learned about the angles. How we will make the angle? Very simple to draw. First we have to draw two rays which intersect over here. Which intersect at a common point like this. So this is going to be the vertex. And these two are the arms. And these are the rays. So this is the vertex and these are the two arms. Now let's see. Now I think you know that what are the angles, and now we are going to see the types of the angle. And I think we have learned in the geometry also. Let me revise that all or recap that all. We had learned about the right angle. What is that right angle? Okay, that right angle is basically derived from the Latin word which is angulus rectus. Rectulus. Now, because that means upright angle. Upright angle, and the 90-degree angle, or basically the right angle, 90-degree angle is also upright like this. And that's why it got a name. It is known as right angle, which is derived from the Latin word which was angulus rectulus. Now let's move on to the other. So we had learned some special angle. This was the right angle, and also let me draw these over here. Right angle, and then we have one like this. What is this angle? Yes, straight angle. So the straight angle, why it is called a straight angle? Obviously it looks straight, so it is straight angle. Very simple to revise that. Very simple to learn this. This is this was the 90-degree angle, and this is the 180-degree angle, which is nothing but the straight angle. Now let's move on. So these was the some special angle. So as we know that if we are going to start, let's say these are the two rays. Let's say that. Firstly, how we will start? Like this. So these two rays overlap with each other. How many degrees it is? 0 degree, of course. Now if I am going to move on and on and on and on, this is the right angle. And if it will move on like this, it is the straight angle. And as we know that the journey don't stop and it moves on and on and on, and it comes over here at its starting point. And when it has taken a one round, and this one is a complete angle because it has taken the whole round. So it is a complete angle. Very simple. Now, as we have learned that when it starts, when the journey of the second ray, this one begins, it comes across like this point. So it is not a straight angle. It is not a right angle, and it is not a complete angle. So what is this angle is? So we had give it a name. It is called acute angle. Or for imagining that, or for learning this, you can say that acute angle small than 90 degree. So acute angle you can remember by this. So we can say that this is a less than 90 degree is, let's say this is the 30 degree. So this is the acute angle. Now let's move on to the other angle, and let's take our marker again. So now we have learned this is the acute angle, this is the acute angle, and now we have reached the right angle. If I will move on, what is this angle? Obtuse angle, a funny name. So this is known the angle which is more than the 90 degree but less than the 180 degree. That is known as the obtuse angle. Let's see the example like this. So this is a obtuse angle. Now let's see some more. So we had reached, let's say we had completed the obtuse angle, and if I will move on, I will get a straight angle. But what if I go on? What if the second ray moves on and it reaches over here? Let's say this and this. Let me tell you. What if it makes like this angle? What is this angle? It has completed the half, the 3/4 of its journey. So what is it called? The angle which is less than the complete angle and more than the 180 degree angle is known as the reflex angle. So what is it called? It is called as a reflex angle. So all the angles between the 180 degree and the complete angle is known as the reflex angle. So let me write down that. Let's say this one. So this is known as the reflex angle. Now, I think the angles are clear to you. And as we have learned, how many angles are there in the total? 360. What is that 360? Why is that 360? So let's see. So we know that angles, when I will rotate all the way, I will get a circle, right? Let's say these are the two markers. Then if I am going to rotate this out, so I will get a circle. So basically, why is there only 360? Why it couldn't be 100 degree? Or why it couldn't be, let's say, 1000 or 500? So why it is not? It is only 360. So now, for that we are going to see a very interesting story about that, and it is a real. I am not going to tell you the imaginary story. So that is the real story. Why does we get only 360 degree? So, but for now, let's stop over here, and that story we are going to learn in our next video. So, for now, let's stop over here, and thank you for watching this video, and if you want any improvement can comment it in the comment box. Thank you and have a nice